In this example, we are trying to match the functions whose graphs are shown from little a to d with the area functions whose graphs are shown from big A to big D, right? And so we're looking at are these original functions. And so basically kind of what we're looking at is if this is the function and we're doing the antiderivative, what did it look like, right? And so if you have a value, if you have this and you do the antiderivative of a constant, like a y equals 2 kind of a thing, and you do the antiderivative of it, you're actually going to create a linear. And so you want to try to put some of those pieces together of like, what's the power? What's the equation on this? And then if you're going to do the antiderivative, you just be looking to do the antiderivative of a 2 dx. Doesn't have a variable. So you would pull in a variable. So then that would give you something like that, right? I don't need to be perfect on this by any means. I just need to get a rough idea that a constant turns into a linear. Just like if you did the derivative of linear, you're turning into the constant. And so if you have little a, and let me kind of spread this out a little bit. Here's all the graphs that you got going on. So that is little a is going to match with C. So A, little a, and C go together. All right. And then if you have something like this, you have a linear and it has a negative slope. So let's say we were trying to make something up of like a negative x, and you do the antiderivative of that, you're going to get a quadratic that is also negative. And so if you kind of just think power-wise, a antiderivative of a linear is going to create a quadratic that is negative because of the original slope. So I can see that B and big B go together. Right? Here, I'm looking at a quadratic. So if I have some sort of a quadratic and I do the antiderivative of it, I'm raising it up a power. All right, I know actually this is a negative quadratic. So then it'll be a negative cubic. And so I'm looking at my graphs down here, what has kind of a negative cubic-ish feel? I don't know. Nothing really. All right, so maybe that's not the right approach to this. So let's do this instead. If this is the antiderivative, or if this is the derivative of something, that also means that this is a slope equation. So a slope equation means you have a slope of 0 at 0 and B. And so the ones left, we're done with this one. We're done with this one. You have slopes of 0 at 0 and B. Well, here's a slope of 0. Here's a slope of 0. Here's a slope of 0. Potential slope of 0. But you have all these positive y values, which means we have nothing but positive slopes along that whole section. Well, this has negative slopes transitioning to positive slopes. This has positive slopes, positive slopes, positive slopes. And it kind of hits its steepest here, which means it would have its highest y value here. And so actually C goes with D. So C and D. All right, now obviously I can process of eliminate to figure out that this graph's going to go with this, but I also want to understand why. And so remember that, again, this was a derivative, and so this represents slopes. And so you have 0 slopes of this graph here, here, and here. All right, so we have 3 0 slopes. We have negative slopes transitioning to positive slopes. You have negative slopes transitioning to positive slopes because you have negative y values connected to positive y values. Let me zoom back in on that. Right, so you have negative y values, which are negative slopes. You have positive y values, which are positive slopes. So that's why D and A go together. All right, so I know I could have process of eliminated that, but I also want to make sure I understand why these pieces are going with each other. And so that was just trying to connect. There's just different ways of thinking of it, but remember that one of the nicer ways is constantly thinking of these equations that, yes, when you do the antiderivative, you're getting areas under curves, but that is a derivative of some original function, which means it's a slope equation. And that's probably the easier way to start to kind of connect the two, that this is an original function and this is a slope equation. Okay, so that was connecting some graphs, derivatives with antiderivatives.